Good afternoon, everyone. Today, in our chemistry class, we will be discussing the topic half-life of radioactive elements. So, first things first. When in other subjects, when you're given a topic to read or do something about it, you always start with the definition. So how will we be defining this? Okay, say the half-life of radioactive elements. We start by defining half because it will be easier before we define life. There are two different words joined together here as a compound word. Half. What comes to your mind when you hear half? You know it from your previous knowledge in your mathematics. You know half is something divided by 2 or half, like 1 over 2. So here you have 1 over 2, which is half. Life, it can be defined as, okay, the total time that someone is given to live during his lifespan. Okay, so we have the definition of life, we have the definition of half. So when they say the half-life of a radioactive element, the half-life of a radioactive element is the time taken, which we know from life, the time taken for half of the total number of atoms given to an element, which it takes to decay or disintegrate. So, not wasting any much of our time, I'll start with an example. So, for example, maybe if you have an element X, if the element X if the half-life of element X is 200 years and the total atoms of element X is 400. So this means that at the end of 200 years, 400 atoms of element X will be divided by 2, which means 400 divided by 2, which is 200. 200 atoms will be disintegrated, while 200 atoms will be left in the atom. Then after another 200 years, which is 400 years, out of this 200, it will also be divided, which is 100. So 100 atoms will be left, 100 will be disintegrated. Let me give you an example with a real radioactive element, which I'll use radium 226. The total life, the half-life of this element is 1622 years. So if at the beginning of 1622 years we have 1,000,000 atoms, at the end of 1622 years we'll have 500,000 atoms left, which means the remaining 500,000 have been disintegrated or decayed. So I'll invite my co-speaker to come give you more emphasis on half-life of radioactive elements.
Good afternoon, class. My name is Mustafa Sabu Kidado, and I'm here to continue what my colleague started. First of all, I'm going to explain what decay constant is. Decay constant can be defined as the rate of change per unit atom of a substance. Now I'm going to explain this on a graph. This is the time, and this is the rate of decay. Now, for example, if you have 100 undecayed atoms in 1,600 years, in 3,200 years, it will be 50 atoms remaining because it will be divided by 2. And if you have in the next 1,600 years, it will divide itself by 2 again, so it will be remaining 25 atoms only at the end of 4,600 years, and it will continue like that till it remains 0. Thank you.
And viewers, I am by name Abubakar Ahmed Sajo. and I will be discussing about the difference between an ordinary chemical reaction and a nuclear reaction. I don't need to waste time on explaining an ordinary chemical reaction because I will believe that we all know that. And then a nuclear reaction that has already been discussed by the previous groups. So let me just jump straight to the point. The difference between an ordinary chemical reaction and a nuclear reaction is the radioactive element. Yes. A nuclear reaction has radioactive elements as the reactant and the producer. So, let me just give an example. This this is 4, this is 2. So this is uranium, this is thorium, and this is helium. This is a nuclear reaction. As you can see, I don't think you are familiar with these elements because they are radioactive elements. But let me just say, in the previous classes that you had, you had an idea about an ordinary chemical reaction. But uranium here is a radioactive element. Thorium here is a radioactive element, which are not ordinary elements. This is an example of an ordinary chemical reaction. So with this point of mind, I hope you have understand the difference between the nuclear reaction and an ordinary chemical reaction. Thank you.
What will happen if the oil reacts of an radioactive element when there are no atoms?
Okay, so this question is what will happen when all the atoms will be gone? When all of them have decayed, when it's zero? Well,
does that mean the atom is destroyed?
Yes, it means the atom is totally destroyed because there are no more atoms left in it.
Totally.
The elements have been destroyed.
Well, according to Dalton's law of Dalton's atomic theory,
Yes.
that atoms can neither be created nor destroyed. So does that mean that theory is not valid?
No, what he's trying to say is that, as we all know,
that theory has been modified.
Yes.
So atoms can be destroyed, atoms can be created.
Yes.
So which means he is right. That's what I want him to tell. Exactly.
Yes.
Yes. So yeah, atoms can be destroyed. Exactly.
Yes.
So any other one?
Last question.
Last question, please.
Sir?
Yes.
Atoms can be destroyed?
Yes.
So any other question?
Through
Theory
nuclear
reaction.
reaction.
Yes.
Wow. That is through decay.
That was
They
what
have
I was
said.
trying to
Yes.
explain.
But under ordinary chemical reaction, atoms cannot be destroyed. Atoms cannot be created. Exactly.